Well, hello. So let's just start quickly. Now let's first draw a circle. Okay. Now if we wanna get the area of the circle, we need to say use the formula pi r squared. Given that the radius of the circle is r. Now this is the first knowledge that we are gonna use in this video. The area of a circle. Now I'm also going to calculate the area using an integral. So let me draw another circle. Let's say right here. Let me make it big. Okay. Now, so the way I will calculate the area as follows. So we are going to take infinitesimal lines like this. So we are going to sum these rectangles, these infinitesimal rectangles. And when we sum all of these, let's say, little tiny rectangles, assume these are straight. My drawing is not that good. Okay, so when we sum these all of these rectangles, we should get the area of our circle. But how are we gonna find the length of each of these rectangles? So how are we gonna, for example, find the length of this specific rectangle? Now, to do this, let's draw another circle and let me show you the calculation. So let's make it white and let's use this color. Okay, now assume that we have a infinitesimal rectangle like this. Okay, well, let's say this is 0. Okay, so this specific point of the circle is at the index 0. And assume that, let's say, we are in a coordinate plane. So this is the x coordinate, and this is the 0, this is the 2r. Because the radius of our circle is r, so r plus r is 2r. Okay, now we said that we are assuming that we are on a coordinate plane. And when we say this is the 0th index, then this is at the xth index. So what I mean is that the distance between the beginning of our circle and this infinitesimal rectangle is x. Okay, now we know that the radius of our circle is r, right? So let's take this to be r. Then we can find actually this point, this length of this line, and that is r minus x. Why? Because this length is x, which is the radius of our circle. I'm sorry, this length is r, and this is x. So when we subtract those two, we get r minus x. Realize that we can use the Pythagorean theorem in here. And also realize that this line and this line are equal in length. So what we can do is we can say a and a in here. So a is half of this line that we wanna find. So this is 2a, the whole of it. Now using the Pythagorean theorem, we can say, let me make it like this. Okay. Now we can say a squared plus r minus x squared equals to r squared. So a squared is equals to r squared minus r minus x squared, which basically means that a is equals to the square root of, let's simplify it, Or let's leave it like this: r squared minus r minus x squared. And we found a, we need 2a, then we just multiply it by 2. Okay, now this is how we can find the length of these infinitesimal rectangles. Now we might ask, what if this rectangle is on the right side of this radius? Because when it is on the left side, we have said that this length is r minus x. But if we are on the right side, then this length will be, so we use the Pythagorean theorem again, this will be r, then this specific length will be x minus r. Why? Because, let me use this color, we are interested in the distance of from here to here, which is x in our case. And we call the distance x again, and this will be x minus r. So the Pythagorean theorem, so these are again a, for the right side of the circle will be a squared plus x minus r squared equals to r squared. Realize that r minus x squared and x minus r squared are the same thing, because when you square something, you take the absolute value of that thing that you are squaring, meaning that these two are the same actually when you square them. Okay, now let's write the integral, the fun part. So let's say integral, we are gonna start from 0 to, here is 2r, so from 0 to 2r, what are we gonna say? We are gonna say sum 2a, which is the length of our infinitesimal rectangles, with respect to x. Why? Because we are constantly changing the x. In one example, x will be here, and in another example, x will be here. If x is pointing here, so if x is at specifically at this coordinate, then we are going to sum this infinitesimal rectangle. So this one. And that's why we take it with respect to x, which is then will be simplified to, let's use another color. Okay, let's use this one. From 0 to 2r, and so let's take the 2 outside of our integral. Let's, instead of a, let's use this expression, r squared minus r minus x squared with respect to x, which can then be simplified to, let's say, equals to integral, or let's first put 2, integral 0 to 2r square root of, and the formula that I'm going to use to simplify this is as follows: a squared minus b squared is equals to a minus b multiplied by a plus b. So using this formula, we are gonna get, okay, so x, let's use this color, x, or why not we use gray again, x multiplied by 2r minus x with respect to x, which will then be equals to 0 to 2r, and then we are gonna say square root of 2rx minus x squared dx. Okay, now this is basically the area of our circle. This is how we can find the area of a specific circle. Now then, we have talked about that the area of a circle can also be written as pi r squared, right? In here. Now, using that formula, we are gonna say, oops, this is equals to pi r squared. Then, when you divide both sides by r, you are gonna get, let's use white in here, dividing both sides by r, you are gonna get integral 2 over r squared from 0 to 2r square root of 2rx minus x squared dx, which is equals to pi. Of course, given that r is not equals to 0. So this basically means that whatever value you select to be r, you are always gonna get pi, except for the ones that r is less than 0. Because if r is less than 0, then you are gonna get negative pi, because you are starting from 0 to 2r. When r is negative, then this will be a negative value, which will result in a negative pi. To prevent that, you can take these into absolute value to get pi, whatever you put is as r, except for the case when r is equals to 0. Okay, so let's just simulate it using Desmos. Okay, so I open my Desmos right now. So let's just put the formula that we found. 2 over r squared integral 0 to 2r square root of 2rx minus x squared dx. And yep, we are gonna say let's take r to be in between negative 10 and 10. Now let's play with the value of r. As you can see, whatever we do with r, we get the pi. Let's make r to be 0, which is undefined. When we take r to be negative, then we get negative pi. And as I said just before, take these into absolute value to get pi, whatever you put instead of as r. So this basically means that wherever you see the pi, you can put this expression instead of using the pi. Well, you are probably never gonna use this expression, but it's cool to know. And that's all for this video. If you have any question, please leave a comment. I will be happy to answer that question, and have a great day.